let's talk about selecting specific elements of vectors or specific rows of data frames. In other words, subsetting. So I'm going to work with two data frames, the air quality data frame that is built into R, and the account data frame, which is built into the reg class package. And specifically, I'm going to define as my variable x the values in the checking balance column of account. So we've talked about, and you know how to refer to specific elements in a particular vector by typing out the name of the vector and then turning on the square brackets and then putting in a number. So if I want the 8th element of that vector, x bracket 8 is going to print out what that 8th value is. And I can go back and I can just by hand kind of count out to confirm that indeed the 8th element is about 111. And we know that we can put in multiple numbers here if we want to refer to more than one element at a time. And that's all well and good, but very often we want to be selecting elements that meet a certain logical condition. Now, by logical condition, I mean equal to a particular value, or not equal, bigger than, smaller than, etc., etc. And so R has its own language for how to refer to elements that meet certain conditions. So let's talk about some of these conditions. I've listed them here, and we'll go through one by one. So if I want to select all of the elements of a particular vector that are equal to some value, I'm going to use the double equal sign. So there's a difference between the double equal sign and the single equal sign. The double equal sign checks equality to a certain value, whereas the single equal sign sets equality. So I can do y equals 8, and that's the substitute for the left-hand arrow symbol that defines a variable called y to equal the number 8. But if I do y double equals, I'm going to do y double equals 4. If I do this, it's going to output either true or false, depending on if this logical condition is y equal to 4 is true or false. So y double equal 4 is false because y is currently 8. Y double equal 8 is currently true because y is equal to 8 here. So if I wanted all of the elements of x that were, say, equal to 0, one thing I could do is I could say, well, what about the output of the command x double equals 0 here? So if I do this, I get a whole bunch of trues and falses. True for whenever the corresponding x is 0, and false when the corresponding x is not equal to 0. So if I look at the first 5 elements, I get a 0, non-zero, 0, non-zero, 0. And so the first 5 elements of the logical condition x double equals 0 is going to match up accordingly. True, false, true, false, true. So one thing I can do is I could say, all right, well, let's just extract out those elements of x that are equal to 0. So by default, if I type out the name of the vector, then some square brackets, and put in a logical condition, it's going to refer to those elements where it finds a true inside those square brackets. So x square bracket x double equals 0 is going to print out all of the zeros in the vector. X double equal 1.4 is going to print out all those elements that are equal to 1.4, and in this case there aren't any whatsoever. Okay. So that's the illustration of the equals. If I want not equals, well, what I can do is preface that equal sign with an exclamation point. Once I do this, that's basically the equivalent of saying, all right, not equals a certain value. So if I wanted all of the non-zero values of x, I could say x square bracket x not equal to 0. And if I run this, I can scan through and I can see, okay, all right, we see a lot of values, then they're all not equal to 0 here. So the key thing is, if I do want to extract out all elements that meet a certain condition, I'll type out the name of the vector, put in those square brackets, and then put in the condition of the elements that you want. And this works for other conditions, greater than or less than. If I wanted to know, well, what are all of the elements of x that are greater than 0, I could type in x greater than 0 as the logical condition, or I could isolate those values that are negative. In this case, we're dealing with checking balances. It might be interesting to see, all right, what are those negative balances? There we go. So less than or equal, greater, greater than or equal. they all refer, or they all match up at what you would expect. Now, sometimes when we're talking about the analysis of missing values, we'd like to know something about how many there are, where they're located, etc. So the air quality data frame has two columns here, ozone and solar radiation, that contain missing values, Na here. So I'm going to extract out those values by left arrowing the ozone column into a vector called y. So if I look at my y's, I see a bunch of Nas. And if I want to say, okay, is the element of y missing, I actually have to use a special notation. I can't do something like y square bracket y double equal Na. And the reason why is that R treats the Na symbol very special. Notice if I try to type this out, I just get a whole bunch of Nas. Not really what I was expecting here. So because R treats Na as a very special symbol, I actually have to make reference to whether or not we do have a missing value or don't have a missing value by using the command is.na. So if I say y square bracket is.na of y, well, here it'll just print out the Nas. If I want all the values of y that are present that are not missing, well, similar to not equal, I just preface the is.na with an exclamation point. And so this will print out all of these present values here. All right, well, sometimes I might want to combine logical conditions. Maybe I would like all of the values of x that are between a certain two values, so bigger than 1 but less than 100. I can combine logical conditions by separating them with either an ampersand, which is R's representation of the word and, or the pipe symbol, the vertical bar, which you can find as the shift backslash key, and that's R's representation of the word or. So for instance, if I want all of the values that are between, say, 5 and 10, we'll say inclusive, the way that I can get these is I can turn on the square brackets after the vector x, and then write two logical conditions. X has to be bigger than 5, or at least equal to 5, and x has to be at most 10. So I can say x greater than or equal to 5 here, and then I'm going to put the ampersand to represent the and then x less than or equal to 10. So let's find all of the values of x that are at least 5, but at most 10 here. Printing those out, we see that makes sense. Now, unfortunately, R is not going to let you write that statement kind of how you want to. Normally in math, we would write something like, okay, if I want to write x between 5 and 10, I'd write something out like this. This is the way that we'd see it mathematically, but R can't actually handle expressions like that. It gives us an error because in order to actually do two logical conditions, at least 5 but less than 10, we actually have to write each one separately and separate that with an ampersand symbol. So we can put as many values that we want here. So we might want to make sure that I could add in also not missing. I'm going to get the same result out, but we can put as many ampersands as we want. We want to have a lot of different conditions on things. All right, the or works similarly. We just use a different symbol here. So let's imagine we're interested in isolating, say, all the really good and the really bad balances here, the ones that are negative and the ones that are very, very, very large. I can do that by turning on the square brackets and writing those two logical conditions separated by an or symbol. So all values that are negative or, say, larger than 10,000. All right, well, negative would mean less than 0, or, the pipe symbol here, larger than 10,000. So if I print that out, I see all the negative balances and all the really big balances. And I can, combine these conditions as I wish. So for instance, if I wanted all values that are negative or larger than 10,000, or say between 100 and 200, well, I can just get clever with my use of ampersands and pipe symbols. That's the kind of computer speak expression for this vertical bar, the pipe symbol here. So how would I write this? Well, x square bracket negative would be x less than 0, or larger than 10,000, or between 100 and 200. That takes two conditions, x bigger than or equal to 100, and x less than or equal to 200. Now, at this point, I actually need to be a little bit careful in how R processes multiple ors and ands. And in fact, it's always a good idea to put parentheses around pairs of conditions or multiple conditions that you want R to consider first. So because between 100 and 200 is a specific condition that I want to make sure that R respects, I might want to put in greater than or equal to 100 and less than or equal to 200 inside parentheses so that R kind of knows that, hey, treat this as kind of like one condition. Now, by default, R will always evaluate the ampersands first, then the ors, kind of left to right, as it would with normal arithmetic. So in this case, I don't really need it, but it's good practice that if you have more complex conditions like this, to wrap those inside parentheses. So printing this out, we see the negative balances, we see the big balances, and we see the balances between 100 and 200. All right, now, one shortcut that we want to be familiar with is the percentage in shortcut. And this is going to be our shortcut for if we have a lot of different ors that we want to evaluate quickly. So for instance, what I'd like to do is look back inside the account data frame and look at the age column here. So if I get a frequency table of the age column, I see that they're all integers here, and I see 22 represented a lot. I see 50 represented a lot. Let's imagine that I really only wanted to look at ages that were multiples of 10. Okay, well this is like a OR condition here. I want all the ones that are 10 or 20 or 30 or 40. And so I could say something like this. I'm going to define X now to be the account $age object here, the age column of the account data frame. And I could say, all right, well, let's print out all of the values that are equal to 10 or equal to 20 or equal to 30 or equal to 40. You get the idea. This is a lot of typing, and it's a bit tedious, and I need to really make sure that I'm covering the entire range of everything. Let's get a quick summary of these. So I need to go all the way up to 90 here. So a lot of typing, kind of annoying. But once I have that, it will print out all of the values here. In fact, there's so many I can't quite see it all. So why don't I put this inside a table command so I can get a frequency table. So a bunch of 20s, 30s, 40s, 50s, etc. No 10s actually, so I could have omitted that condition. Now, if I do run into an instance like this where I'm checking to see, all right, is x equal to this value, or is it equal to this value, or this value, or this value, that's where the percentage in shortcut comes into play. So let's check out what I'm about to do here. If I do x square bracket x percentage in, and then give it a vector of values, 10, 20, 30, 40, 50, 60, 70, 80, 90, what this is equivalent to doing is exactly what I had written up here. Basically, when R sees the percentage in, it says, all right, I'm going to go through all of the elements of the vector that's on the left-hand side of the percentage in, and I'm going to see whether or not they appear in the vector to the right-hand side of the in. So R is going to dive inside the vector x, and it's going to check one by one, is that element equal to 10 or 20 or 30 or 40, 50, 60, 70, 80, 90? If so, I'm going to get out a true. If not, I'm going to get a false. So for instance, let's just look at the first 20 elements of x here. These are all 16s. If I were to run just the logical condition itself, notice that I just get a whole bunch of falses out. So let's do something a little bit more interesting here. Let's look at the first 100 elements. It looks like it's sorted here, so all right, we'll come back to this. So anyway, if I run this command and let's say do a frequency table of this, we can see that indeed I only have the elements that appear in this vector to the right-hand side of the percentage in. So a very useful shortcut when you're looking to see if the elements of x belong inside a certain vector of values. And in fact, I could write this a little bit more efficiently here. I could say x square bracket x percentage in, and then since this is the sequence 10 up through 90, actually just specify this vector, sequence from 10 to 90 by equal to 10 here. So these would give me all my multiples of 10. I can very quickly get out a whole bunch of different values, all those multiples of 10 here. So the upshot is percentage in is useful for checking, and it is x equal to this, or that, or that, or that, or that. Checks to see if x belongs to the elements of a certain vector. The vector the right-hand side of the percentage in is what we're going to check to see if x belongs to, and I'll go through each element of x one by one to figure that out. So that's one way of quickly extracting out elements of a vector that meet certain logical conditions, equal, not equal, missing, present, bigger than, less than, etc. The which command is something to be aware of that does something similar, except instead of actually printing out the values themselves, it tells you where inside a vector you find elements that meet a certain condition. So what I'm going to do is define a custom vector in this case. I'm going to say x is equal to the vector 0, 4.4, 1, 2, 2, 8.8. Put in some NAs in here for good measure. -4, 9, and 20. All right, so here's my vector x. So if I wanted to know if there's any 2's in there, well, I could do x square bracket x double equal 2, and that'll print out all the 2's. Well, sort of though. Notice that I have 2 NAs because 2 of the elements of x were NA as well. So this doesn't always print out what I intended it to print out. So let me show you another way of looking at this. The which command works as follows. The which command says, all right, if I say which x double equal to 2, which says, all right, well, let's dive inside this logical expression and let's report the positions inside the logical vector where I find truths. So if I say x double equal to true, I get false, false, false because I don't get 2's there. I have 2 2's back to back. I have some NAs because I have NAs in the original vector. Which x double equal to 2 is going to report back 4 and 5. Well, the 4th and 5th positions of the vector x have elements that are equal to 2. So there we go, my curiosity is satisfied. If I say which x is less than or equal to 0 here, let's get that equal sign, I'll get 1 and 9 because the first element and the 9th element of x indeed contain elements that are less than or equal to 0. If I wanted to know where the missing values were, I could say which is.nax. And that tells me the 7th and the 8th positions of the vector x contain values that are missing. So it's kind of nice because when we do have NAs present in our vector, the x bracket and then putting in that logical condition is going to output those NAs as well. And if I use the which command, well, the which, because it outputs positions that meet a certain logical condition, I can combine these kind of ideas together to take a kind of more thorough and more accurate subset that matches up probably with my intentions were. So if I want to know, well, what are the values of x that are less than or equal to 0, printing this out, I get those NAs involved. Not very fun, I probably don't want those NAs. But if I say x square bracket which x less than or equal to 0, what's going to happen is that inside the square brackets, because I have that which command, it'll find all the positions of the logical vector where I see truths. So in other words, values of x that are indeed less than or equal to 0. And if I do x square bracket that, it'll report back the elements it finds in those positions, and so it finds the 0 and the -4. So actually combining the square brackets along with the which, I think, is the way to go when you're taking subsets of vectors, because then you don't ever have to worry about NAs. So for instance, if I wanted to figure out, well, give me all the values of the area classification column of the account data frame that I have S's in use, well, let's get some practice with the which. So let's do X is the account $area classification. Get a frequency table here. Get a summary. In this case, there's no NAs, so either way would have been fine. But let's imagine that I just wanted the ones that are equal to S or U. So I could say, all right, well, let's X square bracket X which X double equal to U, or X double equal to S. If I do this, this will print out a whole bunch of S's and U's. I could get a summary of essentially this subset, the values of X that are either equal to U or equal to S. And because I have an or, actually this is kind of custom made for that percentage in shortcut, I can instead say, well, which X is somewhere inside the vector U and S. And I just got to be a little bit more careful matching up those parentheses, and I'll get those same results out. So the upshot is, I think the which command is extremely useful, and I would recommend using that instead of just turning on the square brackets and writing out those logical conditions, because then you don't have to worry about NAs here. So the which command extracts the positions inside of a vector that meets certain logical conditions, and if you put the result of running that which command inside the square brackets, you'll get out those elements themselves. So I could look at a summary of, let's say, all of the values of ozone that are bigger than, say, 5. So if I get a summary of this, here is a summary of all the values of ozone that are indeed bigger than 5. You'll notice that if I didn't have the which, and I just left that as is, those NAs are still going to be in there. And so if I were to change this and actually say, well, give me the average of all the values of ozone that are bigger than 5, doing it the way with which gives me a number out. Doing it the way without which is going to give me an NA, because those NAs prevent the mean function from evaluating. Unless, of course, I strip out those NAs with that additional argument, NA.rm equals to true. All right, so the which command, an indispensable tool that you want to use moving forward, but there's actually yet another way to accomplish the same feat, and that's with the subset command, and it works kind of how you would expect it to do. All right, so let's actually take the air quality data frame once again in ozone. So we have some NAs, we have a lot of values here. So if I wanted to quickly extract, say, all of the elements of X that are bigger than 20, well, X square bracket which X greater than 20 is going to get me there. Here are all the values that are bigger than 20. But there's another way. Maybe you're not too comfortable using which. Maybe you don't like turning on the square brackets. Here's how we can use the subset command to do the exact same thing. So subset is a function that requires a few arguments. The first argument is what you want to take a subset of, in this case, the vector x. The next argument is the logical condition on the elements that you want that vector to meet. So in this case, if I just want the values that are bigger than 20, I'm going to say x bigger than 20. So the way that we read this is, all right, let's take a subset of the elements of x where we find elements of x that are bigger than 20. Same sort of thing, same sort of output. So the logical conditions that we already learned about still apply if I wanted to take a subset of x where all of the elements of x are not missing. In that logical condition after the comma, I could say not is.nax, and that'll print out all of the elements of x that are present. Same thing as running x square bracket which not is.nax. Now, where the subset command I think is a bit more useful is when we start talking about data frames. So the which command can be used to figure out which rows of a data frame meet certain logical conditions, but I think in this case the subset is usually a little bit more elegant of a way to get those rows out. So what do I mean by this? Let's imagine that we're working with the account data frame and we want to restrict ourselves to only rows where we see area classification equaling to R. All right, well in this case I could say let's create a subset. Let's left arrow that to the results of running account, and let's subset the rows using the which command. So how do we get just those rows out? Say just rows where area classification is equal to R. Well, I know with the data frame, once I turn on those square brackets, I want to put a comma in the middle. The stuff to the left of the comma refers to the rows. The stuff to the right of the comma is going to refer to the columns here. So if I want just those rows where I see R in area classification, well, I can use that which command to say which account $ area classification double equals to R, in double quotes because it's text here. And in this case, all right, if I just run this part of the command, it's going to go through the area classification column and it'll report out the positions in that column, essentially the row numbers, where it finds R. So the second row, the fifth row, the sixth row, etc. All right, this command looks relatively verbose. The fact that we've left a blank here after the comma means we want all of the rows or all the columns associated with this. If I run this, I can get a summary of this data frame, and I can see that indeed I just have R's here. But as I was just saying, this looks like a fairly verbose command. And if you're okay with that, well, fantastic. Feel free to just stick with the which command when you're selecting rows that meet a certain condition. In fact, it works just the same as everything else. If I wanted just places where I see R and the checking balance being negative, I can separate those conditions with the ampersand sign and all is well and good. But yes, these commands are getting to be fairly verbose. Let me get a summary of this so we can see that indeed just the R's and we have checking balances that are negative here. You might want to take your subset a different way. Maybe you actually have a lot of different conditions on your rows that you want to be extracting. And so here is how to use subset. Let's left arrow into sub the result of running subset. It's going to work similarly to taking the subset of elements from a vector. I'm going to say what I'm going to be taking a subset of, in this case account, and then I'm going to specify my logical conditions. If I have more than one, I'll use the ampersand symbol for and or the pipe symbol for or. So in this case, if I want to take this exact same subset here, where area classification is equal to R and checking balance is less than 0, what I'm going to do is now I'm just going to take the column name, double equal to R, and I'm going to separate this with the ampersand and checking balance less than 0. So I'm going to run this, I'm going to take a summary, and I get this exact same values for the summary out here. So quick things to note about subset that work a little bit differently than typically when you refer to column names. You'll notice that area classification, the name of the column, doesn't get any double quotes around it. Inside subset, when you're referring to columns, omit those quotes associated with the column names. Now, if you're referring to if that column equals a particular text value or not, you're going to need those double quotes there. But the column names themselves do not get double quotes. Also, if you do have more than one logical condition, an and condition on some of these columns here, make sure to separate them by ampersands. It's very tempting, and I still do this after 15 years of programming, it's very tempting to separate those logical conditions with commas. So give me all the rows of account where area classification is R, checking balance is less than 0, etc., etc. I can't tell you the number of times where I put a comma in here to just represent multiple conditions, but that's not allowed. I need to make sure that the ampersand symbol is separating those multiple conditions. All right, so once we have that subset, I can verify that it indeed got the rows that I wanted. Notice one thing, that no longer do I see these two levels here. I don't see any rows with S, I don't see any rows with U, it might be the case that I would like R to forget about those levels. Oftentimes when you take subsets of rows of a data frame, you're going to take a subset where all of a sudden some of these categorical variables have levels that are no longer represented. So the drop levels command is extremely useful, especially when we start getting into descriptive analytics and predictive modeling, where we're making bar charts or fitting complicated models with these categorical variables. It turns out that because R is keeping track of the levels of that categorical variable separately, even when they no longer appear in the data, R is still keeping track of it internally. That can make some commands a bit more complicated moving forward. So we'd like to maybe get rid of them. So one thing to do very often after you run subset is you're going to want to drop the unused levels. So if I do drop level sub, left arrow that back into sub, what that's going to do is it's going to say, all right, R, forget about those unused levels. So we see area classification only having R in there. So very often, if you go through a very long sequence of subsetting data frames, you'll be running drop levels at the very end of it so that you tell R, all right, all those unused levels of categorical variables, don't worry about those anymore. Very useful if you're dealing with, say, a transactional data from Haynes, where you have, say, items which have multiple different colors or model numbers or something. You might be taking a really complex subset, and originally you might have started with, say, 11,000 different product IDs, and in your subsets you might only have 50 left over. Well, tell R to forget about those, because if you're going to do predictive analytics or make visualizations, it's a lot more useful for R to just handle those levels that are still present in your subset.